Hi, I'm Ross, and what I'd like to talk to you about today is microinverters. Now, an inverter converts the direct current produced by a solar panel into the alternating current, the AC, that's used by your house. So, as review, let's start off with the solar panel. So this solar panel right here consists of 18 cells. It's 36 cells. It's 4 by 9 cells. Each cell is about 6 inches square. Each one of these cells produces a half a volt. A half a volt times 36 is 18 volts. Now, this panel right here, really nicely sized for homeowner install because it's very handleable. However, all the microinverters are tuned up to handle 72 cells, and this is a 36 cell. Well, what do you do about that? Well, the solution is to use these in pairs. And so you take two 36 cell panels, connect them in series, and voila, you have a 72 cell panel, equivalent to as if these came on the very same panel in a slightly different shape. Okay, so now this is producing 36 volts DC. Then what you would do is you take an inverter to take that 36 volts and turn it into alternating current. So this is an N-phase microinverter. This is the most popular one sold in the US. It's also the most expensive one. And you connect it like this. So every microinverter and every solar panel have MC4 connectors or MC4 compatible connectors, and this is what they hook onto. So no matter what microinverter you buy, or no matter what solar panel you buy, they all have the same connectors, which just amazed me. So here we have 36 volts DC going in, and in this case, 240 volts AC coming out. Then what you would do is you would simply plug this into the wall. Now this is you might not recognize it, but this is a 240 volt connector, and if you had a 240 volt outlet, you'd plug that directly into the wall. Once plugged into the wall, you have panels, wiring, and microinverter, and that's all you need. These things go to work right away. Actually, they have a 5-minute delay, but then they go right to work putting electricity into the grid, and they just work all by themselves. Now, that happens to be a microinverter that outputs 240 volts. Well, several of these come in both varieties. This variety right here puts out 240 or 120 volts. So in this case, what you have is this one comes with its own wiring, which is kind of an economical option, and you connect these together. So if you have another one, you simply connect them end to end and they daisy chain together from this wire to this wire, etc. And each one of these handles one panel pair. Now this is an interesting machine over here. This is a microinverter also. It's a more economical choice, but it supports 2 panel pairs. 1 panel pair here, 1 panel pair here. And it has the same daisy chaining cabling so that you can just keep connecting these in a line and connect as many panels as you need. Now, on the other end of this is an example of this particular one happens to be the 120 volt version, and it's connected to a very typical 3-prong 120 volt plug. Just a word about grounding here. Except N-phase, every other microinverter has got a 3-wire cable. Then you have 2 current carrying conductors, and then you have a ground. This makes it really handy because all the grounding is handled just like a normal appliance. Everybody knows that this is the ground lug right here that goes into the plug, and this handles the grounding. Now, the N-phase is a little bit of an exception, because what N-phase does is it has a 2-wire system, and then in order to ground the aluminum frame of the panel, you have to overlay yet another grounding system on top of that, which makes it a little bit harder to work with, especially for the homeowner's installation. but the rest of these are set up better. Now, these inverters just go to work right away as soon as you plug them into the panel and the house outlet, either 120 or 240 as appropriate. But you can't see what they're doing, and so that's why they often sell you monitors like this. These two devices go together. The microinverter company generally makes the monitors, and this reads out diagnostics on every panel that you have, and it reads the individual output of every panel pair. Here's one that goes with NEP. Here's one that goes with Hoy Miles. And the Hoy Miles is an interesting one over here. This particular Hoy Miles serves 4 panel pairs. 1 pair, 2 pair, 3 pair, 4 pair. And they do that because it's more economical to put 4 microinverters in a box than it is 2, and it's more economical to put 2 microinverters in a box than 1. So just in summary, you've got 72 cells, 36 volts DC going into the microinverter. Coming out, you have either 120 volts, which is what you typically see in a house, or 240 volts, which is also in various places in your home, and that powers the house. And next time we'll talk about the monitors and how they work. Thank you.